Okay, fourth graders, take off your shoes. We're doing lots of counting today. I'm kidding. Leave your shoes on. Your mom would appreciate it. Your dog might lick your toes, but that's kind of disgusting. Anyway, let's move on to the math and forget about disgusting dogs licking toes. So today we're going to be adding larger numbers. This is not a whole lot different than adding smaller numbers, except the numbers are larger. Yep, I said that. Anyway, the same rules apply. The difference is that you have larger numbers to account for, which means more place values. Don't be scared. I'm going to show you what I consider to be a mind-numbing tool called the tape diagram. In this instance, it doesn't mean a whole lot. It actually comes into play more as we do word problems deeper into this, and also it may come up a little bit in subtraction as well, and maybe division. But don't worry so much about the tape diagram. If it's something that's a useful tool for you, definitely apply it. But if it's not, then stick with the traditional method. On with the show. I'm going to show you the tape diagram and how it's used. So here is 3,134 as part of a tape diagram, and 2,493 as the other part of the same tape diagram. You're going to be combining those two totals, and you're going to find A. What is A? A is called, and this is your very first lesson in algebra, A is called a variable. You're going to hear that word quite a lot in the years to come. Don't blame me. I didn't make it up. It represents an unknown number, and right now the sum of those two numbers is unknown. Therefore, the sum of those two numbers, we're going to call that A. You could call it any lowercase letter you want, but I like A. And what is the value of A? Well, it's a mystery. It's true, but we're going to figure it out. Now, I'm going to draw a place value chart. You don't have to do that, but for some people it helps. And I'm going to show you what we're doing just because this really spells it out to the nth degree, which means quite a lot. And so, as we normally do, I'm going to start in the ones place and add moving to the left. So smaller place values to the larger place values. I'm helping, and my phone is laughing at me because people want me to buy furniture and rugs, but I'm not going to do it. Anyway, I digress. 4 plus 3 ones is 7 ones, easy enough. 3 plus 9 tens is 12 tens. Now we've already learned up until now that you can't have any more than 9 in a single place value, which means you've got some excess baggage there. You're going to have to take the 10 tens and move that over to the hundreds place because 10 times 10 is 100. We've seen that before. We've used this terminology, but not for probably about a week or so. You're going to move that 10 tens as 100 into the hundreds place. And just to kind of emphasize that, 12 is greater than 9, and that's why I had to do that. So I add that extra 100 in, and I end up with 600s. No need to do anything else there. And 3 plus 2 is 5. Piece of cake. So my answer turns out to be 5,627. It would help if I wrote that, only because it looks a little bit janky right now. And there it is. Mystery solved. On to the next problem. You try, and by that, I'm going to go ahead and write the problem, and I will give you time to solve it, which really just means I want you to pause the video, try this on your whiteboard, and then check back. So you pause now. You may or may not have drawn a tape diagram. That's not significant. I do need you to add these things, but I'm showing you the tape diagram in action, so you're not completely uncomfortable with it when we have to go some point in the future and use it. I am going to give it a little bit of a nudge over here to the left. Anyway, I'll continue. make a place value chart, ones, tens, hundreds, thousands. Oh, and 10,000s too, because we're out to 40 and 30,000. Use your whiteboard, like I said. 40,762 added to 30,000. Yes, there is a comma in there, I promise. 30,473. 2 plus 3 is 5. 7 plus 6 is 13. We know what we do now. We have to move 10 of those tens over to the hundreds place. We now have 12 hundreds, which means we have 10 hundreds. We have to move to the thousands place. Remember, 10 times 100 is 1,000. That's why we're moving it. And that puts a 1 in the thousands place, because before that, there were no ones in the thousands place. There were 2 zeros. And no need to carry any more. We end up with M equaling 71,235. This is pretty straightforward stuff. I don't see you guys having difficulty with this. I'm going to suggest that you probably were pretty good at this in 3rd grade too. Where people sometimes make mistakes is just in the simple addition. I know you move really fast because you tell yourself, oh, this is just so darn easy. I can just get this done like yesterday. I would say take your time, do it right. And, sometimes we teachers say, double check your work. For something like this, if you take your time the first time through, you'll tend not to make mistakes. And so I'm going to say, if that's what you've done, you don't have to check your work. When we correct the answers, you will find your mistakes. We'll point them out at you, and we promise not to laugh. Mostly. So, what's that stand for, Mr. C? I'm going to tell you. M stands for monkey. You knew that though, right? I was going to put a picture of a monkey, but I couldn't find one quickly, and I have work to do. So, we'll have monkey pictures later, I promise. On to the next slide. Now, let's take that one step further. We're going to do a rough estimate here to check the reasonableness of our answers. The reason I'm having you do this isn't so much because I don't trust that your calculation is correct. It's because as you get into the work set, you're going to have to do this. They're going to ask you to do an estimate. This also reinforces the whole idea that you have to round before you do the operation. And you can thank me later, but I saved you. I looked at, this is actually the next lesson. We skipped a lesson. The lesson that I had you skip, I'm not exaggerating the point when I say it was about 25 estimation problems. I thought this was more useful for us because we are doing some estimating as we check for reasonableness, and there aren't as many problems to do. So 32,468 plus 18,759. If you want to go ahead and do that on your whiteboard, I'll tell you to pause it and then come back to me. Okay? Welcome back. I'm going to add 8 plus 9 is 17, carry the 1. Actually, that would be carrying a 10. And then 6 plus 5 is 11, plus 1 is 12. I'm going to carry the 10 hundreds over to the hundreds place. It shows up as a 1. That's how we do the calculation in what we call the traditional algorithm. 7 plus 4 plus 1 is 12. I carry the 1 again. 8 plus 2 is 10, plus 1 is 11. I carry the 1 again. And I have 5 in the 10,000s place. Your answer should be like mine, 51,227. Now, you're going to check your answer for reasonableness. And this is something that I've had to convince kids not to do for 23 years. Don't round your answer. Do this instead. Round the numbers you're adding. There's a name for that, a fancy name. It's add-ins. So add your add-ins. Yeah, it makes sense, right? So add, what's your estimate here? You're rounding 32,000 to the nearest thousand. Why? Because I think that's going to make your check for reasonableness more accurate. So there's 32,000. I'm going to round 18,759 to 19,000. I'm going to round them both to the same place value, happens to be the thousands place this time. And look where my estimate shows up. My estimate then shows up as 51,000. So I'm going to look over at my actual and say, you know, I'm pretty good at this stuff. That's a pretty close estimate. My estimate, my actual compared to my estimate. I mean, this doesn't happen very often, but those are very close in value. Congratulations. Yes, I just compared. Thank you. Are the estimate and the actual close in value? Well, oh yes, I just got through saying that. Why? Well, my theory is because you rounded to the nearest thousand, but it actually goes deeper than that. In both cases, so in 18,759, you are already almost to 19,000. And then on the other number, so you round up, but you rounded down by a similar value in the other number. That's really the only reason it came in as close as it did. If you had rounded them both up, then your difference between the estimate and the actual would be greater. That doesn't make it wrong. That just means that you might, as a young mathematician, question whether or not your answer was reasonable, because I've had kids say to me in a problem like this before, well, Mr. C, my estimate is 3,000 different than my actual. What were the numbers? Well, it was like 60,000 and 63,000. Okay, that's acceptable. If it was 60,000 and 120,000, yeah, there's a mistake in there. Or if it was 60,000 and 6,000, oh yeah, you goofed somewhere. When they're this close with numbers of this kind of value, you're fine. So I'm going to let you set to work. 12 minutes.